Scientific notation is an application of power notation. We use it to write very large or very small numbers in a compact and consistent way. What we do is we write one digit of our number, the first non-zero digit on the left, and then we write a decimal point. Then we write the rest of the digits of our number, and then we multiply the number by a suitable power of 10, so that what we end up with is numerically the same as what we started with. You may hear the words mantissa and order being applied to numbers in scientific notation. You probably don't need to know these words, but if you're interested, this is what they mean. Let's try some examples. Write 60,000 in scientific notation. Well, let's write the first digit of our number, that's the 6, and then, well, in this case there aren't any more digits. Okay, now what power of 10 can I multiply 6 by to get back to 60,000? Let's work it out step by step. We've currently got 6. If we multiply by 10, we get 60. That's 10 to the power of 1. 10 to the power of 2 gives us 600. To the power of 3 is 6,000. And finally, 4 gets us what we want, 60,000. 6 times 10 to the power of 4. Let me show you another one. Write 723 million in scientific notation. So, write the first digit, 7, then a decimal point, then the rest of the digits, 2, 3. Okay, now what power of 10 do I have to multiply this by to get back to where I started? 7.23 times what power of 10 gives me 723 million? Well, here's 7.23. Multiply by 10, 72.3. By 100, 723. And keep increasing the power of 10 until we get what we want. 3, 4, 5, 6, 7, almost there, 8. 7.23 times 10 to the power of 8 is 723 million. Actually, there is a quicker way to get here. The first non-zero digit in our number is the 7. What's the place value of this digit? What's the place value of the 7? It's 700 million, right? The place value is 100 millions, which is 10 to the power of 8. See? Let's try this method on the next example. 605. Well, start by writing one digit, then the decimal point, then the rest. 6.05. Okay, now what was the place value of the 6? Hundreds, which is 10 times 10, or 10 to the power of 2. 6.05 times 10 to the power of 2. Another, 82,000. 8.2 times what power of 10? Well, what's the place value of the first digit? 10,000. That's 10 to the power of 4. So it's 8.2 times 10 to the power of 4. One more like this, a little bit trickier. 24.8. Well, it's 2.48 times what power of 10? Look at the first digit, 2 in the tens column. So the power of 10 is 1. Now I know that 10 to the power of 1 is just 10. You don't actually have to write the 1. But in scientific notation we usually do write the power of 1, just to be consistent with the normal format. So much for large numbers. But scientific notation applies equally well to very small numbers. Let's try it. Write 0.000004 in scientific notation. Well, it's going to be 4 times 10 to some power. What's the power going to be? Well, what's the place value of that 4? It's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, which is going to be 10 to the power of -6. But just to show you that this works, here's how to do it step by step. We've currently got 4. Here's 4 times 10 to the power of -1, which is 0.4. -2, 0.04. -3, -4, -5, and finally -6. This is the number we started with. So 0.000004 in scientific notation is 4 times 10 to the power of -6. Try another. 0.078143. Okay, write one digit and then the decimal point. 7.8143. Now, what's the place value of the first digit, the 7? It's hundredths, which is 10 to the power of -2. 7.8143 times 10 to the power of -2. 0.000306. One digit, then the decimal point. 3.06. What's the place value of the first digit? 10 thousandths. 3.06 times 10 to the power of -4. Okay, another tricky one. 7.01. How will we write this in scientific notation? One digit, then the decimal, is 7.01. And the place value of the 7 is just 1, which I could write as 10 to the power of 0. Remember, anything to the power of 0 is 1. Actually, in this case, most people would just leave the power of 10 off, leaving it as 7.01. Alright, so how do we convert a number in scientific notation back into an ordinary decimal number? Well, that's easy. Just apply the power of 10. Write 8.3 times 10 to the power of 4 as a decimal number. I'll do this first one for you step by step, one power of 10 at a time. This is 83 times 10 to the power of 3, or 830 times 10 to the power of 2, 8,300 times 10 to the power of 1, or finally 83,000 times 10 to the power of 0. Note that we could have got straight here by applying the power of 10 as the place value of the first digit of our number. The 8 goes into the position of 10 to the power of 4, which is the 10,000s digit, 80,000. Then add the rest of the digits, 83,000. Write 2.041 times 10 to the power of 6 as a decimal number. Well, the 2 goes in the 10 to the power of 6 place, which is the millions, 2 million. Then write the other digits, 2,041,000. 6 times 10 to the power of -3. This is a negative power, so my answer is going to be smaller than 1. -3 corresponds to thousandths, so this is 0.006. Write 9.13 times 10 to the power of -5 as a decimal number. Okay, 10 to the power of -5 is 100 thousandths. Write the 9 in this place, it's the 5th digit after the decimal point. Then write the other digits where they belong. 0.00000913. Last example, a tricky one. 2.605 times 10 to the power of 2. Well, 10 to the power of 2 is 100, so write the first digit as 200. Then fill in the other digits, carefully adding a decimal point in the right place. 260.5.